Before you watch the video, make sure you check out my full digital SAT math and verbal section video courses. These are the #1 rated video courses on Udemy, and I'm sure they're going to help you during your SAT prep. In this video, we're going to go over some word problems that we haven't seen in the previous practice session. The word problems that you might see on the exam could be of a type where you need to solve a mathematical equation or provide a mathematical fact. Or they could be of a type where you're given a scenario and you need to judge it based on your statistical knowledge. We have already seen in the course video how those types of questions look like. You already know what to do when you're solving them. But let's take a look here at a couple more questions. And we will also see other more complicated mathematical word problems as well in this session. So let's take a look at question 1. It says here, a study conducted by a mobile phone company found that the average battery life of a random sample of its phones is 4.6 hours. You know, when you do a survey, a poll, or a study, you should take a random sample of objects because that is going to give you more realistic results. That was discussed in a lecture video. There is an associated margin of error of 0.5 hours. Margin of error. So usually in the real world, we give values with the margin of error. We can never be exact because everything in this world has tolerances. For instance, the phone battery can hold up to 4.6 hours. But, you know, in some situations, this could be 4.2. In others, this could be 4.3. In some, this could be 4.61. This is just one number, but one number cannot represent many different phones. Every phone is different. Every phone has been manufactured differently. And some phones could have a defect, etc. Therefore, there is a margin of error that is written in mathematics class like plus minus 0.5 hours, which means that the upper bound is 5.1 hours and the lower bound is 4.1 hours, and everything in between is what they have recorded to be the amount of time the battery of that phone can hold. The study was then repeated with a much larger sample size. So whenever you are using a much larger sample size, you usually get more correct results. Because if you test only 2 phones, one of them could be faulty, then your results are 50% wrong. But if you test 3 phones and one of them is faulty, then your results are only 30% wrong. If you test 100 phones and one of them is faulty, then your results are only 1% wrong. So, you know, when you increase the sample size, your results are more precise. That's a great way to remember this. Okay, so the study was then repeated with a much larger sample size, with the mean and margin of error of the new sample being calculated in the same way as the original study. The sample size has the same mean calculation, yeah, and the mean in the past was 4.6, but now we have a different sample size. Its mean is calculated and its margin of error is also calculated. Which of the following is most likely true? So as I stated, before we look at the answer choices, we make our own conclusions. When your sample size increases, you have less error, okay? That's just how it is. So A, the margin of error from the new study is larger than the margin of error from the original study. Not really. The sample size increased in the new study. So the margin of error, the amount of error you can make should decrease because you have more phones. So that should be more correct. You should get to the correct result more. A goes away. B, the margin of error from the new study is smaller than the margin of error from the original study. That could be. Let's read C. The mean from the new study is larger than the mean from the original study. I don't know about that. Nobody told me the mean from the new study. C goes away. D is also about the mean. D goes away. Mean is something that is calculated. The margin of error is something that we can already base our make conclusions about. And I'll prove it to you. For now, the answer is B, and that's the correct answer. But let me prove it to you again. So my example with one phone, two phones, three phones, that was already kind of like a proof. But let's say you want to understand what people think about, let's say, about apple juice, okay? You want to understand what the common opinion about apple juice is. And you go to only two people. And one of them says, I like apple juice. The other one says, I don't like apple juice. All right, then it's 50-50. But what if you go and you ask three people? Two of them say, I like apple juice. The other one says, I don't like. Oh, now it's a bit different. How about if you go here to more people? And that day, this guy doesn't like apple juice because on that day he is just on diet. This guy likes apple juice because he bought a lot of it. He has to drink it. This guy doesn't like apple juice because he all of a sudden got an allergy. This guy likes apple juice because it's the season. This guy doesn't like apple juice because it's too much sugar. Everybody has their own preferences. Now you see a whole range of outcomes. Here, you only had two outcomes. That's not really safe. You cannot just go ask two people and they will give you an answer and you'll say, oh, the entire world is 50-50 on apple juice. 50% of the world like it, 50 don't. You can't say that because what if you just came across a person who likes it and across a person who doesn't like it? It could be luck. But the more people you take in your survey, so let's say you took 20 people, I'm going to continue drawing, the less is that luck factor, because out of 20 people, if 20 of them say, I like apple juice, what are the odds of that? That means people really like apple juice. If out of 20 people, 19 say, I don't like apple juice, then the majority of people don't like apple juice. But if out of 20 people, look, if out of 20 people, 18 people say, I like apple juice, 2 people say, I don't like apple juice, that means the majority like apple juice. But if you took those 2 people, those last 2 people that don't like apple juice, and you ask them, you would think that 100% of people don't like apple juice just because of these 2 people that said, I don't like it. So it's very important to increase the sample size, because the larger your sample size, the less error you're gonna have, the less outliers you're gonna have. Okay? Good. I hope that makes sense. Now we're gonna continue with the next question. So in such questions, always read the scenario. The scenario is very important. 2 different store owners in a shopping center estimated the percentage of all visitors who wear eyeglasses. They estimated it. The keywords are very important. They estimated. They're not sure, they're just estimating. They each selected a random sample of the shopping center visitors and recorded whether the visitors were wearing eyeglasses or not. The results from each sample are shown in the table below. So sample A, there are 21% people wearing eyeglasses and margin of error is 3%. Sample B, 21% of people wearing eyeglasses, the margin of error is 2%. So what does that tell us? Well, if the associated margin of error was calculated the same way for both samples, the associated margin of error was calculated the same way for both of them. Which one is the most likely reason that the result for sample A has a larger margin of error? What could be the reason? And I'm telling you, it's because of the sample size. Because If you take only 2 people and ask them, do you like apple juice or not? They're going to say yes and no. So it's going to be 50-50. But if in the reality, if you go to a larger sample size, a very large, you'll find out that the situation is different. Out of 20 people, 18 will like apple juice, 2 will not. So it's not going to be actually 50-50. It's going to be 90 to 10. 90 versus 10. And the more people you take, the closer you get to the actual number. The closer you get to the actual number. If you only have 1 person in your sample, you're very far from the right answer. If you have 1 million people in your sample, it's very hard, but you will be very close to the right answer. Okay? So the fact that here the margin of error is larger, it is because the sample size must have been small. And when your sample size is small, you are prone to making more errors. So let's read A. A, sample A included more visitors than sample B. Not really. Sample A included less visitors. B, sample B included more visitors than sample A. Yes, that could be the right conclusion. Let's see if there are any better conclusions. C, sample A included greater percentage of visitors who were wearing eyeglasses than sample B. And no, because the percentages are the same. 21, right? And therefore, D is also incorrect. C and D, they are talking about percentages, but the percentage of people wearing eyeglasses is the same. So the margin of error is all about the sample size, okay? Good.